Imagine you just bought a massive industrial 3D printer, like one of those rigs that can print an entire multi-story house in a single afternoon.
Oh, right, the ones where you just load the schematic and let it run.
Yeah, exactly. You hit a button, the robotic arms whir into action, and by dinner time, there's this stunning building sitting on your lot. The facade is gorgeous. But then you walk inside.
And that's where the problems usually start.
Right, you walk in and realize the 3D printer doesn't actually understand physics at all. Like, there are absolutely no load-bearing walls. The plumbing is inexplicably routed straight through the electrical panels, and the entire foundation is basically held together by, industrial duct tape.
Which is a terrifying thought to actually live in.
Completely. But here's the thing. It's June 2026, and if you listen to the whispers sweeping through the tech industry right now, this is exactly what is happening to software development. We are living through an unprecedented architectural boom, but the structures we are building are, well, terrifyingly fragile.
Yeah, the output speed we are seeing today is largely an illusion. We're witnessing this massive acceleration in generating the accumulation of structural fragility.
So today, we are taking a deep dive into this phenomena. It's known as vibe coding. We're pulling from a massive stack of sources, developer rants on Hacker News, enterprise data, academic postmortems, open source manifestos. We want to answer one critical question, which is, what happens when the developers stop typing?
Which is a huge shift.
It is. Our mission today is to unpack what this superpower actually is, look at the dangerous doom loops it creates when the machines hallucinate, and go over the hardcore frameworks you need to adopt if you want to survive this shift without accidentally destroying your own projects.
Well, to really critique this shift, we first have to understand the sheer addictive gravity of it. We can trace the popularization of the actual term back to early 2025.
Right, Andrej-Karpathy. Right.
Yeah, exactly. Karpathy famously described the process as fully giving in to the vibes and forgetting the code even exists. He was talking about using tools like Cursor Composer, where you just describe your intent in plain English, and then you just blindly hit accept all without even reading the resulting code diffs.
It's just such a wild statement to make, especially for someone with his pedigree in AI.
Yeah.
But, if you compare it to the traditional way we've built software for 50 years, you start to see the appeal.
Oh, absolutely.
Because traditional coding is brutal, right? It's
Yeah.
meticulous manual labor. You are typing line by line. You're defining the logic. You're managing syntax, constantly catching edge cases. You have to hold the entire architecture in your head all at once.
Which is mentally exhausting.
Exactly. And vibe coding just flips that entire paradigm on its head. You just provide the intent, like, hey, make a sleek login screen with a dark mode toggle, and the AI handles all the plumbing for you.
And beyond just saving keystrokes, there is this really profound psychological mechanism at play here. When we look at the neuroscientific analysis from Amplify Labs on this trend, vibe coding is effectively the digital evolution of the flow state.
Oh, interesting. Like getting in the zone.
Yeah, developers are curating these hyper-specific, low-stimulation environments. So they use ambient music, controlled lighting, and they pair that sensory setup with AI co-pilots like Windsurf or Klein that actually adapt to their specific working rhythm.
So the tool actually syncs to your brain's frequency, in a way.
Kind of, yeah. You don't hit a random syntax error that jolts you out of the zone anymore. The AI anticipates your next move and just smooths over all those micro frictions.
Wow.
So the friction of implementation just vanishes, leaving the developer in the state of pure, uninterrupted ideation. It's incredibly seductive. Even Linus Torvalds, the notoriously exacting creator of Linux, recently admitted to vibe coding a Python visualizer for his audio noise project.
Wait, Linus Torvalds,
Yeah.
the ultimate purist of code quality?
Yeah.
When someone like him adopts a tool that abstracts away the code itself, a fundamental industry shift has occurred.
Yeah, it sounds a lot like stepping into the role of a film director, rather than having to be the cameraman, the lighting tech, and the lead actor all at once. You just sit in the director's chair, point at the set, and shout, "Make it moodier."
Right, and the crew just scrambles to make it happen.
Exactly. The AI crew adjusts the lighting, swaps the lenses, but what happens if that robotic crew doesn't actually comprehend the abstract human concept of moody? They might just shatter all the bulbs on set and plunge you into pitch black.
And that is the core vulnerability right there. When the AI misunderstands the human vibe, the underlying intent, the resulting fallout is often catastrophic. And now that we have a year of hard data on this trend, the hangover from this coding party looks exceptionally painful. let's talk about that hangover, because I was looking at the numbers, and they are alarming. Wikipedia cited this recent CodeRabbit study of open-source pull requests, and it shows that AI co-authored code contains 1.7 times more major issues than purely human-written code.
Yeah, that's a huge spike.
It is, and more terrifyingly, it has 2.74 times higher security vulnerabilities. We're looking at massive incidents like the Lovable App disaster.
Oh, right. That was bad.
Yeah, where over 10% of the web apps generated by a specific tool, I think it was like 170 out of 1645 apps, had active data leaks exposing personal information. So we aren't just generating ugly code, we are deploying dangerous software at a massive scale.
We are, and the security risks are compounding, but there's an even more fascinating psychological trap hidden in the data. If you look at the METR evaluations of frontier AI models from early last year, it's wild. They found that experienced open-source developers were actually 19% slower when using these AI coding tools.
Wait, slower?
Yes, but when surveyed, those exact same developers felt they were 20% faster.
Wait, how are they feeling faster, but actually measuring slower? Is that just the dopamine rush?
Basically, yeah.
Like you pull the prompt lever, you watch 300 lines of complex code just appear instantly, and you feel like an absolute supercoder, completely discounting the 3 hours you just spent tearing your hair out trying to trace a phantom bug the AI introduced.
Exactly. That dopamine hit masks the invisible technical debt being created. Because the generation phase is instantaneous, but the debugging phase is agonizing. If you spend any time reading the raw, unfiltered discussions on forums like Hacker News or Reddit, the reality check from developers actually in the trenches is brutal.
What are they saying?
They're explicitly saying that debugging Vibe-generated code borders on the impossible because you completely lose the source of truth.
Because when you write the code manually, you know exactly where the logic lives. You know why you made a specific decision on line 42.
Right. But with this new paradigm, you aren't actually debugging code anymore. You are debugging an AI's undocumented, hallucinated assumptions.
Which sounds like an absolute nightmare.
It is, and it leads to what developers call the "it still works" trap.
Well, what kind?
It's when the application appears to function perfectly on the surface. So you keep prompting the AI to add more features, you keep hitting accept all, but underneath the hood, the system is secretly rotting.
Oh, man. You know, product discovery coach Teresa Torres highlighted a brilliant example of this. She dubbed it the vibe coding doom loop.
Yes, the doom loop.
Yeah, if you're listening to this and you've ever tried to build a quick web app over a weekend using an LLM, you have probably hit this exact wall.
Yeah.
She was building a health tracker app for her dog. And as she iterated, she kept changing her mind about what the interface should look like and how the data should be entered.
Which is completely normal. Iteration is a normal part of the creative process, but it exposes a massive mechanical flaw in how large language models handle software architecture. I mean, most robust software is built on multiple synchronized layers, right?
Yeah.
You have the data layer where the actual information lives, the controller layer that manages the business logic, and the view layer, which is the user interface.
Ah, right, the classic model view controller architecture.
Mm-hmm.
So you tell the AI to tweak a button on the screen, the view layer, but the AI forgets to tell the database to actually expect the new data format.
Exactly. And the LLM forgets because of its context window limitations. Large language models don't inherently understand global software architecture. They just predict the statistically most probable sequence of tokens based on their immediate prompt.
Right.
So when Torres changed her mind about the user interface, the AI agent updated the visual code perfectly, but it drifted out of sync with the data and controller layers. And over 10 or 15 prompts, these layers drifted so far apart that the bugs just became intractable. The underlying logic was fundamentally contradictory, and the AI couldn't fix it.
So what did she do?
She literally had to throw the entire weekend's work into the trash and start completely from scratch.
Okay, I have to push back here for a second. Based on everything we just discussed, haven't we basically just invented a slot machine for software engineering?
A slot machine?
Yeah. Like, we sit at our desks, we pull the lever, we get a massive dopamine spike when the prototype magically renders in the browser, but we are secretly racking up a mountain of technical debt. Aren't we just trading the cognitive load of writing the code for the much, much worse cognitive load of deciphering a robot's tangled, undocumented mess?
Well, if developers use these tools without extreme discipline, it operates exactly like a slot machine. The industry has realized this over the past year, which is why the conversation has drastically shifted away from just marveling at the magic trick.
Right, now it's about survival.
Exactly. It's about building rigorous frameworks to tame the machine. The goal now is using this responsibly in production environments.
So since we can't unring the bell, let's break down some of those survival frameworks. One of the best foundational rules floating around the developer community right now comes from Simon-Willison, and it's incredibly simple. Never commit code to production that you couldn't explain to someone else.
Which is brilliant because it forces human accountability back into the loop. It directly combats the Karpathy accept-all habit we talked about earlier. If you cannot explain the logic, you do not understand the assumptions that AI made.
And if you don't understand it, you cannot maintain it when it inevitably breaks.
Precisely.
But if you can't abandon AI entirely, where's the line? The consensus emerging among developers right now seems to be the 70-30 rule from the DEV community guide. Have you seen that?
Yeah, where you aim for 70% AI-assisted work, right?
Exactly. You let the agent handle all the tedious boilerplate, the formatting, the basic CR root operations, your standard create, read, update, and delete functions. But you aggressively gatekeep that remaining 30%.
And that 30% is strictly human territory.
Strict. Reserved for system architecture, complex business logic, and security protocols.
And keeping the architecture human-led is exactly how Teresa Torres adapted after her dog tracker app collapsed. She realized that trying to iterate while coding with the AI was what was triggering the doom loop, so she instituted a really rigid plan review fix cycle.
Okay, how does that work?
Well, before a single line of code is generated, she prompts an AI agent to write out a comprehensive plan for the feature in plain text.
Oh, so just the logic, no code. And she doesn't stop there, right? Doesn't she take that plain text plan and feed it to a completely separate AI agent?
Yes. She sets up an agent explicitly prompted to act as a plan reviewer. And this reviewer persona's only job is to aggressively hunt for logical flaws, missing error handling, and architectural inconsistencies in the plan.
That's smart.
Yeah, and only when the plan survives that gauntlet does she move to the actual implementation phase. The separation of concerns is just vital here. She applies the exact same friction to the code itself, using a code reviewer AI persona to check for test coverage and security flaws.
I love that.
But her most critical rule is regarding bug fixing. She says you should never let an agent fix a bug without forcing it to diagnose the problem first.
It's like a patient demanding surgery from a doctor who refuses to even look at an X-ray. If the AI doesn't explicitly output why the system is broken and you just scream, "Fix it," into the prompt box, the model will just blindly hallucinate chunks of replacement code.
And usually introduce 3 new bugs in the process.
Exactly. You have to decouple the diagnosis from the execution.
There is also a secondary manual strategy gaining a lot of traction right now, popularized by developer Sean Godek. He calls it refactoring to understand. He argues a really profound point. The code itself is not actually the most valuable artifact in a software project.
Right. The most valuable artifact is your understanding of the code base, your mental RAM.
Exactly. When you utilize vibe coding, you will inevitably hit a threshold where the system's complexity outpaces your mental model. When you get lost in the AI's generated labyrinth, Godek suggests you must manually rewrite and refactor parts of the code yourself.
Just to wrap your head around it again.
Yeah. The act of manually tearing it down and rebuilding it is basically the only way to restore your mental map.
And documentation from modern AI native development environments like the Kiro IDE, they back this up entirely. They suggest that 50% of vibe coding shouldn't be generating new features at all. It should be vibe refactoring.
Which is crucial because LLMs are notoriously bad at creating clean, shared components.
Right. They just generate massive amounts of duplicated, redundant code. You kind of have to act as a gardener, constantly pruning the code base to keep the rot at bay.
Yeah.
But wait, if I'm listening to this and I realize, okay, I have to spend half my day writing plain text plans, running separate AI code reviewer personas, and then manually refactoring the code just so my human brain can understand what the robot did, hasn't vibe coding completely failed its primary promise? Like, is this actually saving us any time?
That's the big question. And at the scale of a tiny personal project, sure, that overhead feels really heavy. But when you zoom out to the enterprise scale, the time savings are undeniable. It just fundamentally alters the developer's job description.
How so?
Well, look at recent enterprise automation reports from places like Hexaware and Emergent. A complex project like building automated device drivers traditionally takes a team of 5 engineers 3 full months. But utilizing these AI frameworks, teams are building minimum valuable demonstrations, basically working prototypes in a matter of weeks.
Wow. Weeks instead of months.
Exactly. They're cutting initial development costs by up to 70%.
So the speed to market is unprecedented, but things are still going to break. And when an enterprise-grade Kubernetes cluster breaks, you can't exactly just delete the repository and start over like a weekend project.
No, you definitely cannot.
And that's where this wild new concept of Vibe debugging is stepping in to save the day, right? I was reading about Resolve.ai doing this.
Yes, vibe debugging is fascinating because vibe coding allows us to break production systems faster and in more convoluted ways than ever before. The industry is developing AI agents specifically to investigate the fallout.
Because traditionally, investigating a complex cascading failure is a brutal serial manual process. Like a developer checks a telemetry dashboard, then reads through Git commits, then pulls logs from individual containers, sequentially trying to piece together a timeline.
Right. It takes forever. But vibe debugging turns that serial nightmare into a parallel process. Instead of a human scrolling through endless lines of logs, an AI debugging agent spins up 10 concurrent threads.
Oh, wow.
Yeah. One thread is querying the Kubernetes pods of virtual containers running the code, while another is cross-referencing recent Git commits, and a third is scanning raw server telemetry. It processes all these hypotheses simultaneously and synthesizes a natural language narrative of exactly what broke and why.
That's incredible. So it really feels like we are entering an era where we deploy robots to write the software, and then we have to deploy a second set of robot detectives to figure out what the first robots broke.
Exactly.
And the human is just the manager caught in the middle, adjudicating between the machines.
Yes, the human engineer is elevated to a managerial role. But this massive macro shift carries devastating implications for the broader tech ecosystem, specifically the open source community.
Right. There's that fascinating academic paper circulating right now, bluntly titled, Vibe Coding Kills Open Source.
It's a sobering read.
Yeah. The argument is that relying on AI models inherently homogenizes the code we write.
Because LLMs predict the most statistically probable next token based on their massive training datasets, they will almost always suggest the most common, well-established libraries and frameworks, so they will default to React or Python's standard libraries because that is simply what they've seen the most.
So it creates this massive self-reinforcing feedback loop. If the AI only suggests the massive libraries, the newer, highly specialized or niche open source tools get completely starved of oxygen.
Exactly. They just die out.
And more importantly, if the AI is writing all the implementation, the human developers aren't spending hours in the open source community forums anymore.
Right, and the ecosystem relies on that friction. When humans struggle with a library, they submit bug reports, they ask questions on forums, they contribute patches, they interact with the maintainers. By removing the friction of coding, AI removes the human engagement that sustains the entire open source ethos.
That is so sad.
It really is. The maintainers of these vital foundational projects are left screaming into the void, while AI agents silently scrape their past work.
It's a heavy, unsettling thought, because vibe coding relies entirely on the open source community's past labor to train its models. But the very act of using the AI might be starving the vibrant community that creates this shared knowledge in the first place.
We really have to seriously question the long-term sustainability of our shared digital infrastructure.
Yeah. Bringing this all together, if there's one thing for you listening to take away today, it's that vibe coding is not a passing meme. It is a massive tectonic paradigm shift in how digital tools are created. It absolutely democratizes creation, allowing anyone with a clear idea and plain English to conjure software into existence. And for veteran engineers, it supercharges that highly addictive flow state.
But the cost of that speed is extreme vigilance. You can outsource the typing to a machine, but you can never outsource the understanding. You have to fiercely guard your mental RAM. You must plan ruthlessly, review ruthlessly with separate AI personas, and continuously refactor to avoid falling into that doom loop.
Exactly. So look at your own workflow. Whether you are hacking together a weekend passion project or you are managing a massive legacy enterprise system, ask yourself,
Right.
are you actively maintaining your mental map of the architecture? Or are you just staring at the AI spinner, chasing that dopamine hit, and blindly hoping the underlying logic holds together? The tools we have today are impossibly powerful, but they are utterly reckless without a confident, informed human operator forcing them to explain their work.
Couldn't agree more.
Which brings us to a final, somewhat provocative thought to leave you with. If we follow this current trajectory, wait, let me rephrase that. If we follow this current trajectory, if AI handles all the initial code generation, and eventually, through parallel vibe debugging, it handles all the complex investigation and bug fixing, what happens to human intuition?
That is the million-dollar question.
Right. Because historically, a great engineer's intuition isn't learned in a textbook. It is forged through years of struggling with syntax, fighting with broken systems, and painfully tracing logic errors in the dark. If we completely remove that struggle in a decade, will developers actually know how to build software from first principles?
Or will they just be highly paid AI whisperers, completely locked out of the inner workings of the machines they supposedly control?
Exactly. Think about that massive 3D printed house we talked about at the beginning. If the AI built it overnight, and the AI is the only entity on Earth who knows how the duct tape plumbing actually works, what happens to the rest of us when the tape finally wears out? Thanks for joining us on this deep dive. Keep questioning the tools you use, and we'll see you next time.